Okay, I can start lah. Okay. Okay, as we seen as in our screen, now we have a circuit of combined with series and parallel. And as you can see on your left, we have measurements for the voltage. And as you can see at there, we have a resistor for R1 that is 10 ohms, and R2 is 20 ohms, R3 40 ohms, and R4 5 ohms, and finally R5 is 15 ohms. And on your right side, we have measurements for each of the resistor with currents. And as they given us in a digital form, and we have been created these circuits in breadboard. And that's it for me today. Okay, let's start again. Okay, as you said, we have disconnected the 10 ohms, that is the first resistor on the circuit. And as you can see, bro, can you zoom in a bit the circuit? Okay. So as you can see, we disconnected the 10 ohms resistor, and of course we cannot, the current cannot pass through the resistor since it's not in a parallel way because it's in a series. In series, the current have to flow from one point to one point. If anything at the middle we have disconnected, or we have any blockage, and the current we cannot flow. So for this scenario, for disconnected 10 ohms, there is no current passage. So the voltage for all resistor have passed through is zero, and the current to all passing through all the resistor is also zero. We can prove this using Ohm's law too, but I think there is no necessary using Ohm's law in here also, to be honest. Okay, bro, next. As you can see in front again, we have disconnected the 40 ohm resistor that is parallel to each other to the 20 ohms. So in this scenario, the current can pass through all resistor because parallel we have a two-way options. If one we don't have, one option is blocked, the current can pass through into another resistor or into another part. So that's why we have a current all around the other resistors, including this is for voltage measurement. And on your right side, we have for the current measurements. And you can you can calculate the total value of the current each resistor getted by using Kirchhoff law, Kirchhoff voltage law, or you also can use Ohm's law, V equals to IR.
Okay.
Okay. Okay,
Okay.
this is the normal resistor lah, and as we use and we just add a short circuit, and that's like this lah. This is how we came. So now if the current want to flow, it will flow to the place that it have a high chance to pass the current. So kalau macam ni resistor dia serak sikit kan.
Hmm.
Okay, kalau ada resistor dia tak akan pergi macam ni lah. Dia pergi ikut, dia keluar kat sini. Dia tak masuk sini. So current flow sini memang kosong lah.
So short circuit tu add wire je lah.
Add wire macam dia ambil shortcut lah. Dia tak nak pergi kat sini. Macam dia pergi kat long way supaya dia boleh fully pass the current. Faham?
Oh.
Bro, this is
Now,
my...
let us see to the circuit that is disconnected, resistor 20 ohm. The 20 ohm resistor is parallel to the 40 ohm resistor. So when the 20 ohm resistor is disconnected, the circuit for this graph, this graph will become series. So the resistor effective is 10 ohm plus 14 ohm plus 5 ohm, then plus 15 ohm. Then you can calculate the current source by using the ohm's law, voltage source divided to the resistance effective. So you can get the current source that is 171 milliampere. Then you also can using the Kirchhoff voltage law and the Kirchhoff current law to calculate all the voltage and current that flow through the resistor. Then you can get the answer same with the result in the Tinkercad. So next is the circuit that is connected resistor 5 ohm. When the resistor 5 ohm is removed, the circuit will become the open circuit. So the voltage and the current cannot flow completely in the circuit, so they will not have the voltage and the current show at the ammeter and voltmeter for the each resistor. And the next one is the circuit that disconnected resistor 15 ohm. This condition is same with the last one, the circuit disconnected resistor 5 ohm. The circuit also is a open circuit. It means the current and the voltage cannot flow completely in the circuit. So all the voltage and current will be shown zero. So next, I want to pass it to Khaleeq.
So I will talk about short circuit at resistor 5 ohm. As you can see, we put the wire across the 10 ohm resistor, and then the current flow to the wire and not at 10 ohm. So that's why there's no volt at resistor 10 ohm. But they have a current through the resistor and wire, because this refer to Kirchhoff current law. And then for the short circuit at resistor, wait, short circuit at resistor 20 ohm and 40 ohm, we put the wire across R2, which is 20 ohm and 40 ohm, and there's no voltage at the R2, same as we put the wire at resistor 5 ohm. Yeah.
This 20 ohm, this 40 ohm. Then we add one short circuit.
Ah,
If normally there is no the short circuit, the current will flow through here and here. So
yes.
the 20 ohm resistor and 40 ohm resistor that has current. But if you
Mm.
plus one short current, the short current didn't have the resistor. So the
Mm.
resistance is zero. The current will flow through uh the circuit that is lower resistor. So all the current will go through the short the short circuit. So there is no current flow to the 20 ohm resistor and 40 ohm resistor. So both of them is 0 volt, 0 ampere.
Oh, but there's have a voltage. No voltage too.
No voltage too,
Oh,
because V equal to IR. If your I is 0, your voltage same with a 0.
ah, okay. I understand. Understood.
or we short circuit for the 5 ohm resistor, right? So there isn't current flowing, so it will be 0 volt. According to Ohm's law, which says that V equal to IR and I equal to 0, so V will equal to 0. So as we see on the right side, also for the short that we have make to the 5 ohm part, okay, so there isn't current flowing, so so as we will see, it has 0 ohm for 5 ohm resistor. All right. So as we see for 15 ohm resistor, we add wire to short circuit at resistor which has a resistance of 15 ohm. So as we see, we have 0 voltage in it, and according also to Ohm's law, which says that V equal to IR and I equal to 0 in this case. Okay, and also as we see on the right side, Also, we short circuit for at 15 ohm resistor, and as we see, we have zero current flowing according to Ohm's law too.